Well, good morning. It's great to be here. I hope you're enjoying it as much as I am. I certainly really enjoyed the trade show yesterday and the talks we've had so far. So what I'm going to talk about today is about cross-reality, but this is a beach near my home in New Zealand. We have beautiful black sand beaches, and you can see the islands out there. It's a lovely environment. One of the most interesting things about beaches, of course, is it's where the land meets the sea. And at that point, you have a lot of interesting life forms that can live in both places. You've got starfish that can be on the land or in the water, crabs and mussels and the like. And in many ways, we right now have an interesting boundary between virtual reality and reality. So people sometimes think these things are separate. And really, the goal of virtual reality is to separate people from the real world and to create this illusion that you're somewhere where you're not. But as I'll talk about today, the boundary between reality and virtual reality is where a lot of interesting research and activity can happen. So many of us, of course, are familiar with this reality-virtuality continuum that was first posited 30 years ago, 1994. And here Paul Milgram said that you can arrange computer interfaces in a continuum depending upon how much they replace your real world. So on the right-hand side is virtual reality, the left-hand side reality. And of course, in the middle is augmented reality and augmented virtuality. And this is, we're now very familiar with the term mixed reality. But some more interesting things can happen when you start thinking about transitioning along the reality-virtuality continuum. So many people think interfaces just exist as discrete points. So you go to the trade show and you try a VR interface or an AR interface. But imagine you could have a device that lets you move all the way along this continuum from the real world into immersive virtual reality and transition as you like across that. Now, why would you want to do that? Well, because different points along this continuum are useful for different things. Virtual reality might be useful for storytelling and immersing in a fantastic space. Augmented reality might be good for face-to-face collaboration, where you've got a headset and you can see content in the space between you. So being able to transition across this continuum would be a very useful thing to be able to do. A second interesting way to connect across the continuum is to connect between points. So you could imagine you've got all your interfaces here, and somebody in augmented reality is now wanting to communicate or connect with somebody in virtual reality. So you can have remote collaboration. Or maybe somebody in the real world wants to connect with somebody in augmented reality interface, or in other ways as well. So you want to be able to create interfaces that support collaboration, again, all the way across this continuum. So a good example of this is some work we did a long time ago now in 2001. We developed a system called the Magic Book, and the idea with the Magic Book was to create a real book, and you could read the real book like normal, but then you could open the pages of the book, put a headset on, and you could see AR content come to life. And then you could also, if you saw a scene you liked, be immersed inside that and into virtual reality. So this is one of the very first examples of a transitional system. Here's a video of the system working. This is a long time ago, so my hair's not so grey, and we're reading this Japanese book here with my friend Bruce. We designed special handheld displays so you could take them off your face easily without having to wear anything. And we could look at the pages of the book, and as you open the book up, these little characters come to life. And of course, 20 years ago, this was amazing, but now this is a kind of old hat. But you can imagine being able to transition inside these scenes here. So you can see here we've got this little virtual world, and then I can transition inside, and now I'm in the VR space. And the interesting thing is this is a collaborative system, so while I'm in the VR space moving around, my friend who's in augmented reality or in the real world can see me as an augmented reality character in the real world. So this little pink blob here is me moving around in the virtual world. So we have this multi-scale collaboration. Of course, if I look up into the sky, I can see my friend looking down at me. Now, this is very, very crude graphics, but even today, it's quite unusual to find interfaces that let you seamlessly transition between the real and virtual world. So this is an example of a cross-reality system. And cross-reality is really an emerging technology focusing on the concurrent use of transitioning between multiple systems at different points along this continuum. And there's really three different types of cross-reality systems. One is transitional systems, so being able to move between AR and VR or real world and VR. Substitutional systems where you take a regular object and use it for something else in AR or VR. And also a multi-user system where you've got multiple people experiencing different realities. And the Magic Book I just showed you is an example of all three of those things. You have, of course, it supports transitioning between the real world to AR and VR and vice versa. It uses a regular physical book that we're familiar with, but when we look at the book through the headset, it becomes something magical and different. And then also, there's a multi-user AR/VR collaboration that you've got multiple people. You could be in the AR scene, or somebody else could be in the VR scene. So this is becoming very important because now we're starting to see more research in this area. So some examples here of systems that allow multiple people to collaborate together or use familiar devices in AR or VR, or having, on the right-hand side, there's a real monitor with virtual displays around it. And so if you look at the number of publications, in the last 4 years, there's been a dramatic increase in academic papers in this site. And of course, finally now, the industry is catching up. So with the Vision Pro, for example, with Apple, they've got the crown on the top, and as you dial the crown, you can smoothly move between seeing the real world and immersive virtual reality. And then you've got a number of examples of companies that provide mobile phones that plug to headsets, so you can use a mobile phone as an input device with an AR smart glass display. So it's becoming a very, very hot topic. And I think going forward, I think in the next 5 years, almost all the displays you see will be supporting AR and VR together. You won't have to take a separate display off to have an AR experience and then put another one off for a VR experience. If you're a manufacturer, you'll have to make sure that your display enables you to seamlessly transition between the real world and VR and back and forth. So I want to talk about a few research directions in this space. Of course, there's many possibilities, and we don't have much time. But I'll just talk about these few areas. First of all, using familiar devices to enable you to interact with AR and VR content. Secondly, prototyping tools and being able to make these experiences very easily. Third, how you can use these types of experiences to enhance communication. And then finally, to talk about asynchronous collaboration as well. So first of all, cross-device interaction. So this is where you can use the same device in an AR or a VR setting. So, for example, there's a picture of somebody using a mobile phone and bring the mobile phone into VR, or a Logitech's MX ink pen, where you've got a regular-looking pen and you can sketch an AR or VR with the pen. So the goal is to have a single input device that you can use in different realities, like the book that we did there with the Magic Book. And one example of this is a project we did a few years ago called the Second Sight. And the idea of this project was to combine a head-mount display with a mobile phone or a handheld display. In this case, though, we wanted to make sure the phone was the primary display and the head mount or the smart glasses was providing a secondary input. And the reason why you want to do that is because the head mount display provides a very wide field of view. But of course, when you spread the pixels over a wide field of view, you don't get much resolution, whereas the mobile phone has a very high resolution and a very small field of view. And also the mobile phone provides very precise input, touch input and stuff on the phone. So we developed a system called Second Sight. You can see here the person is using an AR display with the phone, and around the phone you put additional content. So there's a map application, and as they look at the map, they see tags floating around the phone, and they can tap on the tags and see information popping out about the restaurants around them in space. And then they can arrange that so they can see it. So it takes their phone screen and lets you use the whole world as your phone screen. But you can still use the phone screen for input, so you've still got the high resolution touch input and the like. Now, that looks very nice, but to make that was very complicated. So it turns out when you want to prototype systems like this, it's very difficult. You have to think about programming for multiple devices. You have to be able to have multiple interfaces. You have to be able to do hardware and software prototyping. And so many of you may see on the trade show or other places some very nice tools like Niantic Studio for rapidly prototyping AR or VR experiences. You can't use those tools for doing something like this. So behind the scenes, in that little implementation, you can see we had this set up here. We had the old Meta glasses, the wide field of Meta glasses. We had this set of cameras that was tracking the glasses and the phone. The glasses themselves were connected to a large desktop PC, and we had the Unity game engine and a networking system as well. So hardly anything that's really portable. But luckily, some people now are starting to make prototyping tools that make it much easier to build these types of systems. So for example, Google this year released a library called XDTK, which is a cross-device interaction toolkit. So you can see in the video here, the person's using their mobile phone to rotate these AR objects, and then they can use their smart watch to do the same thing as well. So this is a Unity plugin, and it makes it very easy to stream data from different sensors into your AR application, and then have a cross-device interaction. So you can use the watch or the phone for interacting with AR. And even better, this toolkit released 2 years ago called VRception. This is from some researchers in Germany, and they were the first ones to build a multi-user, multi-environment rapid prototyping toolkit for non-experts. So this really allows you to develop cross-reality systems where you can go from the real world to immersive VR. And here's a video of this working. So you can see here, is it starting? Oh, hang on a minute. It should be playing. Oh, I'm really sorry about that. Huh. Oh, well, I'm sorry about that. In the video, it showed the ability to be able to transition between the real world and immersive VR, and being able to place arbitrary screens and interaction points in the video. It's a really nice video, but please email me if you'd like to see that. So the third thing I'd like to talk about is enhancing communication cues. And this is using virtual cues to improve collaboration. So here you can use AR or VR to show things like the gaze or point of interest, to represent remote people, so you can see an AR avatar appearing in the real world, to put shared objects of interest in the space as well. So some work we've done in that space is look at how we can show communication cues we don't normally see in the real world. So here's an example of a collaboration between AR and VR users. We have one person in the real world wearing an AR display, a second person in a different environment using VR. We take a scan of the real world, and so the person in VR is in a copy of the AR situation. And then in that environment we have avatars like you can see in number A, but you also add this view frustum that you can see in number C and D. And the view frustum shows where the other person's looking. And this is very important because normally you can only see where somebody's looking if you can see their face. But with the view frustum, I can see where you're looking even if I can't see your face. And so that means we can collaborate together really well even when we're not looking at each other. So this video here shows that. On the left side is the real world, the right-hand side is the virtual copy. This is what it looks like in AR. I can see the pink head of my collaborator. And then you can see the blue lines come out of their face, or the pink lines. This shows the view frustum. And so it shows where the person's looking. So even though I can't see the person's face, I can see that they're looking at this green cube here. When the person moves forward, they can move into view. So when we did some studies with this, we found that being able to show the viewpoint of the other person where they're looking significantly enhanced collaboration. So we can use AR or VR communication cues you don't normally have in the real world. And then the fourth thing I want to talk about is about asynchronous collaboration. So this is where you can use collaboration across time in the same place. So on the left-hand side there, you see a person sitting in front of a monitor with an AR display on, and then when they put the display on, they can see on the right-hand side, right of that, you can see a blue blob. That's the viewpoint of the person who was there before them. So they can see what somebody else was doing at that location before them. Or in the middle panel, there's an AR note that somebody added, and on the right-hand side, people looking at the object that somebody added as well. So we want to be able to build systems that allow us to record what we're doing in the real world or VR and then play it back at some later time for people that want to collaborate with us. A good example of that is a project we did last year called Time Travelers. And you can imagine that you're in a factory and there's an expert, and what they have to do is they have to take parts from a storeroom and take it to a workbench to assemble an engine or something. So the person goes and grabs the parts and then takes it to the workbench and does the work. And then you can imagine sometime later, you've got a person who's a novice who's learning how to work, and they need to do the same thing. We can use augmented reality to show what the person did in the first case, and they can just follow the same behavior. So they're not sure how to do the job, so we can now play back what the person did before them. So to do that, there's really four parts of the system. First of all is recording and playing back somebody's actions. So we build a system that allows you to, using the magic leap and object tracking, is to record people's head and hand movement and object movements, and then to play that back at a later time. So you can see here the person starting the recorder, and then in AR they can grab the object, this cube here, and start moving it around. And we're creating an AR recording of what they're doing. And then they can stop the recording. And then later on, we can play that back. So he pushes the play button, and then he sees this avatar come and pick up the virtual copy of the cube and move it and place it on the square, on the table again. So that's the first part of the system, being able to record and play back. The second part is being able to support different views. So I've just shown you an example of an AR view where you can see the AR content. But we can also look at a VR version of that same experience. So this is the VR version here. And we can also manipulate objects in VR as well. And we actually have a world of miniature view. So we take the VR version of the real world and shrink it down and put it into an AR scene so we can see that as well. So we have multiple views. And because it's a cross-reality system, we can easily move between these different views depending on what we want to do. Then the third part is being able to provide feedback. So it means that while I'm watching the video, I can add some annotations, and so somebody can come later on and query that and ask what's happening. So you can see here in the AR case, the person is now putting green circles down and recording an annotation. You can record a voice annotation that goes with the visual cues and ask questions like, what is that? And you can do the same thing in VR as well. So now in the VR case, he's pointing at those locations and asking some questions. And then the final part is being able to support multi-user collaboration. So you can see here, we've got one person walking around following this virtual avatar, and then you've got a second person as well in that same space. So you can have multiple people in the real world, and you can transition between the AR and VR scene as well, and they can work together looking at that recording also. And we also have some very intuitive user interactions that seamlessly let you transition between those environments. So this is moving between AR and VR, so you slide the slider, and it slides you into the between the VR and AR environment, and then the reverse going between AR and VR as well. And then you can also have a virtual replica of the real world, which is that copy of the block you've got there as well. So that's 4 examples of cross-reality research directions. There's some really exciting technology that's coming out that will change and make it even more possible to do more interesting research. And one of those things is some advances in head-mounted displays. So we're getting head-mounted displays that are becoming smaller and more ergonomic, like you can see the Ray-Ban glasses on the bottom. But also you've got displays with integrated sensors. So on the top here, this is the OpenBCI Galea display, and the Galea has 8 EEG sensors at the back. In the face plate, they've got a wide range of heart rate sensors, EOG sensors, facial EMG, and eye tracking, and some other sensors as well. So when you're wearing VR systems like this, you can then look at how you can have much more enhanced emotion recognition, or you can measure people's cognitive load. And then, of course, you can combine this with AI as well. So you can imagine AI-enhanced communication where the virtual avatar that you're seeing in AR actually has an AI brain behind it and can start communicating with you and talking with you like Alvin just showed, and connecting with you in different ways as well. So there's a lot of different research directions that are possible in that sense. And one area that we've done is a project a few years ago called Neural Drum. In this case, we looked at how we could measure people's brain activity and use that to automatically transition between the real world and the virtual world as well. So now instead of manually going across that continuum, we used your brain activity to transition based upon how much your thoughts were in sync with the person you're working with. So we built a collaborative VR drumming experience, and we measured the brain phase of the phase of the brain electrical signals from each person, looked at if they're in sync or not, and if they became synchronized, then we started transitioning between the real and virtual world. And we use that just using some simple EEG electrodes. So here's the video working.
Neural Drum is a VR drumming experience that allows 2 players to drum together while their brain signals are simultaneously measured. At first, you can set some daily objects on a table to use as drums. A player will use 2 drumming sticks to play the game. Both of the players will wear an EEG capturing hardware to get their brain signals measured from the frontal lobe. The data acquired will be streamed to the data processing system to enhance VR experience, depending on the player's collaborative performance. We designed a software to calculate the phase locking value, which is an index of neural synchronicity, for the FP1 and FP2 channels of the theta band from both the participants. When synchronization between two players is low, the camera will be more clear to do so, whereas when synchronization is high, the vision becomes more obscured with each point cloud eliciting higher particle effects. We logged and analyzed the user's brain signals, as well as had them answer a subjective questionnaire regarding their perception of synchronicity with their partner and the overall experience during a pilot study. We discussed design implications to further improve neural drum in our paper.
So that video you saw, as we started drumming, when I became in sync with the person across the table, then it transitioned so I could no longer see the person. It transitioned to a VR scene where I saw more virtual effects and they faded away into a VR environment. So that's one example of the type of application you can build using EEG-enabled headsets. And what we found when we did that, you can see on the left-hand side, these are some recordings of people playing the game. When people weren't playing very well, then the green lines show when they're hitting in time with each other. Then when they weren't playing very well, then they didn't feel much in sync. And when they were playing very well on the right-hand side, you see a very good player. And you had comments like this. It was quite interesting. I actually felt like my body was exchanged with my partner. So when you start getting in sync with somebody, you have interesting communication behaviors. So just to recap, what I've talked about today is I've talked about cross-reality systems and how they support transitions between the real world and the virtual world, but also connection between people at different types of interfaces. So if I'm using my mobile phone, I should be able to connect with somebody in VR, or I'm using my AR display, I should be able to collaborate with somebody in the real world, or vice versa. So cross-reality systems really allow you to support collaboration between all the different XR manifestations. And I really believe that the current generation of headsets, the Apple Vision Pro and the Quest 3 and the Quest 4 and other devices from there on, will all support this type of ability to see either the real world or immersive VR. So as designers, we need to start designing for that and think of experiences where you can be able to easily support interaction across all of those continuums as well. The other important thing is that we need to think about how to bring VR and XR devices into our everyday workflow. So if we're working or playing, we should be able to use our phones or other everyday devices as input into those environments. So I showed you that with the Magic Book and using a book, or with the second site using a mobile phone to interact with AR. So I talked about several important research directions, looking at how we can support interaction across devices, building prototyping tools that makes it very, very easy for designers and developers to explore this space, enhancing communication cues, and then asynchronous cross-reality so that you can collaborate with people that aren't even there with you at the same time. But of course, there are many other possibilities as well. There's a lot of interesting work we can need to be done around privacy and security, around scaling this up so you can have one person collaborating with hundreds of people. And then over the next year or two, you'll see a huge explosion of activity happening when you can start combining AR or XR and AI, and Alvin talked very well about that just before, and also with a wide range of new sensors. So for example, maybe in AWE 2030, you'll be wearing some headsets and you'll see me on stage as an avatar talking to you, and you'll be able to talk to me, but at the same time, my avatar is attending a meeting in New Zealand or Australia, or I'm attending a wedding somewhere else in the world, and you can make a digital twin of yourself that could be anywhere, and hundreds of twins all over the world collaborating, because the avatars are built are smart enough that they can communicate with me and look like me, and to all intents and purposes are me. So there's a really big opportunity in exploring that space where you're starting to take XR and combine it with AI and sensing. So I'm about out of time. Of course, I've shown you a few different projects today, and this really isn't my work. This is the work of my lab. So here's the people who've passed through my lab over the last few years. And we're looking for collaborators, so if any of you are interested in this topic, please come and talk to us. I'll be around the rest of the day. And if you like, I can also send you a copy of the presentation with the video working this time. So please get in touch. This is my contact details. Here's my lab website with a lot more projects, my email address, and my Twitter handle as well. So thank you very much.